Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Baraa.T, and I am a student in the University of Khaduri. And this is the second assignment of the operating system subject. We will talk about mutual exclusion. Mutual exclusion, it is a technique used in concurrent programming to ensure that only one thread can access a shared data or resources at the same time. This is important because when multiple threads try to access and modify the same data together at the same time, it can lead to what we called it race condition, issue known as race condition. What is a race condition? A race condition happens when the final results depends on the unpredictable timing of threads. This can cause incorrect or inconsistent data. Now let's talk about semaphore. Semaphore, it is similar, but instead of allowing only one thread, it can allow multiple threads to access as a resource at the same time, depending on its value. And we have spin lock. Spin lock works differently. Instead of waiting efficiently, a thread checks if the lock is available. This is called busy waiting, and it can waste CPU resources if not used carefully. So be careful. Now, Matex solves this condition, but it can reduce or introduce other problems if not used carefully. We have a potential problem, deadlock. Deadlock happens when two or more threads are waiting for each other to release locks. And none of them can proceed. For example, if thread A holds lock 1 and waits for lock 2, while thread B holds lock 2 and waits for lock 1, both threads will be stuck forever. To prevent deadlocks, we can use techniques such as acquiring locks in a fixed order, or using timeouts when waiting for a lock, or avoiding holding multiple locks at the same time when possible. Um, and we have another issue or another problem. It is priority inversion. Brighton Virgin, it happens when a high priority thread is blocked by a low priority thread that holds a matrix. Meanwhile, a medium priority thread may run and delay the low priority thread from releasing the matrix. As a result, the high priority thread is indirectly delayed. To solve this problem, systems can use a technique called a priority inheritance. In this method, the low priority thread temporarily inherits the high priority until it releases the matrix, allowing to finish faster. To understand this more, we have a real world analogy or a real world example. Imagine a bathroom that has only one key. If someone wants to use the bathroom, they must first take the key while they are using it. Of course, no one else can enter after they finish. They return the key so that another person can use it. This key represents the matrix, and it ensures that only one person access the resource at the time. Uh, Now we have a code example using C++. We will move to Visual Studio to see it. Now we have the first one without mutex. Without mutex, here I created two threads, and each thread tried to increment a shared variable. Here it is the counter variable. The shared variable that's called the counter. We will increase the counter 100,000 times. Okay, but the answer will be unexpected because this is we use without. This is the first version without mutex. Let's run it. Look at the answer, 100, and it's not too. it's not predictable. So let's run it again. It changes every time because we didn't use the mutex. The second one, we will use the mutex on it. And this is the second code. This code is with the mutex. Output becomes correct here. Let's see. It becomes consistent and correct, which is exactly 200 thousands, as we can see here. And we know that mutex prevents race conditions and ensure data integrity. But using mutex incorrectly can also cause problems, as we said before, deadlock. It happens when two or more threads are waiting for each other to release locks, and one of them can persist. And another issue, it is the priority inversion, and it happens when the high priority thread is blocked by a lower priority thread holding a mutex, which can delay important tasks. In conclusion, mutual exclusion is a fundamental concept in operating system. It is essential for protecting shared resources and avoid race condition. Um, with the use with the quotation like did and bore in the bore performance. Understand the difference between mutex and semaphore spell lock. It's good and important. It must be used carefully to avoid advanced issues like deadlocks, priority inversion. Um, and this is my project. And thank you for listening. Wassalamu alaikum warahmatullahi wabarakatuh.